Welcome to this training video. My name is Chris and today we're going to talk about geometry performance optimization. This is part 1 of the artist optimization series, and this episode will give a high-level understanding of what impact geometry can have on games performance. This video will cover general performance info, amount of triangles, small triangles, shadow geometry, and overdraw. General performance info. When we say performance, it translates to the work the processor has to do in a time unit. If the work is more than the processor can do in a fixed unit of time, we call this loss of performance. And in games, we often talk about frames per second. What that actually is the update frequency of the game, aka how often something can change within a second. If things does not update fast enough, our eyes see it as laggy or off. It does not look naturally. If our game must have at least 30 frames per second, it means that all calculations the processor do must be done in 0.03 seconds. So if the processor gets more work than it can handle in this time, the processor will still continue and finish that frame. But say in a bad spot, a frame takes 0.09 seconds. It may not seem that much, but the result is a game barely running at 11 frames per second. Now, there are many things that goes into a frame, and in the following sections, we're going to look into graphics and geometry, and what you as an artist can do to help with the performance. Amount of triangles. For the following parts to make sense, we need to clear out what the word process means. When a triangle is processed, it means that the geometry the artist made is transformed into 2D pixels on your screen. This section is otherwise very straightforward. The GPU, aka the graphics processor in your machine, has a hardware limit of how much it can do each second. Reducing the amount of triangles simply gives the processor less to do. A small amount of triangles is fast to process, a larger amount takes longer time and is worse for performance. Small triangles. This one is a bit trickier as it may not be obvious that we lose quite a bit of performance on processing small triangles. The smaller they are, the worse the GPU feels. And if a triangle is smaller than 1 pixel, well, the GPU is in performance hell. So let's look at some stats. If we fill an entire screen with equally sized triangles and test different sizes, this is what we get. When the triangles are smaller than 8 pixels each, we start to notice a problem. If we get below 2 pixels, well, it's bad. But under 1 pixel, it's really bad. I mean, if we have 100%, 1400% is well, off the chart. So why is it like this? Well, let's look at certain clear examples. If a triangle is less than 8 pixels, we can see we have an issue. Each triangle processed is turned into a block of 8 by 8 pixels, called a primitive. If a triangle is really small, we still create a block of 8.8 pixels. In this example, we're wasting 63 pixels and only rendering 1. This is bad for performance. Another example is if a triangle is less than 2 pixels. Now we start having problem with our quad pixels. Blocks of 2 by 2 pixels used to compute derivatives. These are, for example, used to select MIP maps when filtering. So again, if a pixel is smaller, we always use 2 by 2 pixels and pixels gets wasted. Last example, what if something is less than 1 pixel? If a triangle is smaller than 1 pixel, aka subpixel, all hell breaks loose. All GPUs are built to work on sizes larger than 1 pixel. If something is smaller than this, a lot of really expensive magic must be done instead. How to optimize. The first thing is be smart from the start. Basically, it means that you need to think through your work before committing. Spend some time looking into this asset and how it will be used. For example, make sure that you build your mesh with the amount of details that can be seen in-game and not close up zoomed in a Maya viewport. And should your asset be animated? Are all those edge loops and vertices really necessary? There are many more things that can be considered, but basically plan out your mesh and use only vertices where needed and with a detail level that can be seen in regular gameplay. To keep a good performance and a good detail level, a level of detail setup is almost mandatory. LODs. LOD or LODs are versions of your mesh with less triangles and less small triangles than the version before. Each LOD step and only that is displayed at a specific distance from the camera. This allows you to have details up close and also have a version far away with details removed. This is in order to get good performance. Let's look at a game example. In these pictures we see two ratmen with a wireframe visible. In this picture, the rat to the left is in its original and highest detail step, the one to the right is in its last. Very often are LODs made only to reduce amount of triangles. This is a huge problem as we now know. So in order to make sure that your LOD step has less smaller triangles, you must look at the distance where it's turned on by the game. This is the only way to see what the camera will see. Shadow geometry. In order to create shadows, the shadow system also needs to use a mesh to project the shadows from. The system needs to process one mesh for the regular graphics and one for the shadows. But it's not really that simple. When using shadows, you're doing a few things to optimize the performance. One of these things are splitting up the shadows into level of detail steps. In shadows, these steps are normally called cascades. The system uses one mesh for each cascade. With 3 cascades, this becomes a total of 4 meshes, including our original mesh. There might be other splits in the shadow rendering that might need to use our mesh even more times, but in this case each mesh will be used 4 times. And by used, I mean that each frame this mesh is processed 4 times. How to optimize? One thing we can do is create a specific mesh that's only used for shadows. As the mesh is used multiple times, it's even more important to keep the amount of triangles and small triangles to a minimum. Overdraw. Overdraw is quite expensive, and what it means is that some pixels get drawn several times. They get overdrawn. If 2 meshes were completely separate and rendered on their own, the GPU is happy, because then a sorting system can decide what to process. However, if these 2 objects were inserted into each other and combined and then processed, it will cause overdraw. For the system to make sense of this, it still needs to render one object at a time, so it will first draw the smaller cube and then the larger cube. You can think about it like a painting, where you first paint something and then on top of it paint something new. Your brush has then painted the same area twice, but you can never see the first object. You have overdrawn it. This is bad, as we never want to paint something if you never can see it. We're wasting performance. So when does this happen in game? Well, take a look at this rubble pile. It's made by sticking many objects through a dirt pile. It's more clear in the right picture where you can see it from underneath. How to optimize. Always try to stitch all meshes together, so it's just one solid surface. If this is not possible, at least remove all geometry inside another geometry, even if you have to do more cuts. Overdraw also affects shadow meshes, so these things should be done to them as well. Recap. These are the key takeaways from this session. Use less triangles, as the processor has a limit of how many triangles that can be processed each frame. Use less small triangles, as the GPU does its calculation in bulks of several pixels. If a triangle is smaller than the bulk, we're wasting pixels and thus performance. Use level of details on your mesh. This way you can still have details up close and less amount on small triangles far away. This saves performance. Create a shadow mesh an optimized version of your regular mesh. The shadow system needs to render it many times each frame, so it must be cheap. And finally, stay away from overdraw. Do what you can with your mesh and avoid pixels being rendered multiple times. Thank you for listening. My name is Christer Larsson. Stay tuned for more training videos. And as always, if you like what you see, please subscribe.